Hi guys, I'm Dr. Sid, and today I'll be teaching you chemistry behind homemade bombs. Hello. So, this is Bao Chao, the bomb expert, and this is his minion Chao Ta. So, Bao Chao has been in jail for 3 times and is now part of the Yellow Ribbon Project. And today, he's going to teach us some tips on how to make bombs at home.
So guys, how do you make a bomb? Firstly, you need to take sodium bicarbonate and put it in the bottle and insulate the top with tissue paper, which my minion has already done for our sake. The next thing you need to do is to add vinegar into this bottle and close it real fast, which my minion will now demonstrate. Let's start. And now you shake it. And there you have a bomb. And guys, this is your classic explosion. Do be reminded that we are trained professionals and do not attempt this at home.
So, after you've seen the explosion, let me tell you about the chemistry behind this. So now, I'll explain to you the chemistry behind this homemade bomb. So as we all know, vinegar is made up of ethanoic acid and water, and baking soda is actually sodium bicarbonate. So when we put these two together, this reaction occurs. And this is an acid-carbonate reaction which produces carbon dioxide, which built up in the bottle and caused the explosion. This seems to be a simple acid-base reaction, but actually there's more to it. Bicarbonate ion reacts with water to form H2CO3, which is carbonic acid, and hydroxide ions. Carbonic acid also forms water and carbon dioxide reversibly. So in fact, carbon dioxide comes from 2 reactions. However, as we look at these 2 reactions, both carbon dioxide and water are produced. Since the second reaction is reversible, we can apply the Le Chatelier principle. More and more carbon dioxide and water are being produced from the first reaction, causing the equilibrium of the second reaction to shift to the left, thus favoring the backward reaction, and more carbonic acid is produced. So what we can actually conclude from here is that 1 mole of sodium bicarbonate does not yield 1 mole of carbon dioxide due to the reversible reaction. In other words, yield of carbon dioxide is not 100%. Moving on, why do we consider sodium bicarbonate as a base? According to the Arrhenius theory of acids and bases, acids are substances which produce hydrogen ions in aqueous solution, while bases are substances which produce hydroxide ions in solution. So why is sodium bicarbonate a base? Now, let us refer to another theory called the Bronsted-Lowry theory of acids and bases. According to this theory, an acid is a proton donor, while a base is a proton acceptor. And proton here actually refers to hydrogen ion. So let us take a look at this reaction. Bicarbonate ion and water gives carbonic acid and hydroxide ion. We can see that to form carbonic acid, bicarbonate ion is to accept a hydrogen ion. Thus, bicarbonate ion can be considered a base. On the other hand, H2CO3 is a hydrogen ion donor, thus making it an acid. As such, bicarbonate ion and carbonic acid form a conjugate acid-base pair. And in the same reaction, water donates hydrogen ion, while hydroxide ion accepts a hydrogen ion. So water and hydroxide are another conjugate pair, whereby water is the acid and hydroxide ion is the base. So this is why sodium bicarbonate is a base. And this whole experiment appears to be a simple acid-carbonate reaction, but it's actually more complicated than it seems.
You may be thinking, what is the use of baking soda and vinegar apart from making a bomb? Well, first, it can clear a clogged drain. Half a cup of vinegar, another half a cup of baking soda, when added to the drain and then washed down by boiling water, can help to clear the clog, as the mixture will break down fatty acids into soap and glycerine. Furthermore, the carbon dioxide produced by the reaction would be able to be strong enough to propel a model rocket. Therefore, this reaction can actually be used to test out prototypes.